Same idea. I'm saying let's do h of x over k of x. So first thing we're going to do is we're going to set this up and we're going to say, all right, h of x goes on top. That is x squared minus 16. Be careful. H of x was written second, but they asked for it to be in the numerator, so we have to make sure that that goes on top. The bottom is going to be 2x squared plus 9x plus 4. Okay, so again, let's go through and factor this. Okay, we're going to say the numerator factors into x plus 4, okay, and x minus 4. Okay, so I want to show you a little trick. Okay, if you don't want to have to go through the AC factoring process every time, we can say if this is going to work out, we need there to be one of these two expressions on the bottom, or else nothing's going to cancel. So since I have strictly positive numbers in here, it would have to be x plus 4. I couldn't have an x minus 4 in the bottom because that would make something negative somewhere in the problem. So I could say, you know what, let me just take a guess and say, you know what, maybe there's an x plus 4 in the denominator. What my goal is going to be is to figure out what would have to go here to complete the problem. Well, in order to get a 2x squared when I only have an x, I would need a 2x here, right? X times 2x gives me the 2x squared. In order to get the 4 at the end, I would need a positive 1 here, right? Because 4 times 1 gives me the 4. The only thing I need to do is to check that when I multiply the inside pieces and the outside pieces, that I'm getting the 9 that I should get. In this case, if you notice, I have an 8x and a 1x, and that's the 9x. Okay, so we can kind of use the information that we were given in the original, in the numerator, and say, well, an x plus 4 has to be there, so let's just check and see if that's the factor. So it saves us a little bit of work having to AC factor everything, but again, if you're not comfortable with a little shortcut, don't use it. Only use it when you feel comfortable with it. In this case, x plus 4 on top, x plus 4 on the bottom cancels, so my quotient is x minus 4 over 2x plus 1. But let's not forget that we have some domain restrictions, right? The original squared functions don't contribute anything. They are all real numbers. However, right here, okay, I'm going to say x plus 4, this factor cannot be 0. So let's find out what makes it 0. Well, negative 4 makes this one 0. 2x plus 1 would also make a 0. Okay, so let's find out what makes that 0. Well, it's negative 1/2. Right, so I'm going to say again, I'm not allowed to have these two numbers. X is not allowed to be equal to negative 4 or negative 1/2. Okay, so this is my domain restriction, okay, on the original function. So it's also my domain restriction on my answer here. So my final answer is this right here. Okay, two-part 1 to letter A. Okay, the second part says to evaluate h over k, or h divided by k of 2. So again, if you remember back from one of our first videos on function notation and operations with function notation, we said you could evaluate a 2 here everywhere, or you could also do it in the end. So again, I want to show you both. So if I were to plug into my original function h over k, and I plugged a 2 in, what I'd get is I'd say, well, that's 2 squared is 4, 4 minus 16 is negative 12. Okay, and I could plug this 2 in also here and here and say, well, this is 2 squared is 4, 4 times 2 is 8, okay, plus 18 plus 4. Well, 8 plus 18 is 26. 26 plus 4 is 30. Okay, so this is the fraction negative 12 over 30. So let's just leave that for a second and see what happens in my new function. If I go to the answer, the work that I've done, and say let me plug in a 2 there, well, it's going to be the same thing. I'm going to say this is negative 2 minus 4 over 2 times 2 plus 1. Okay, so this looks like it's going to be negative 2 minus 4 is negative 6. And on the bottom, I have 2 times 2 is 5. 5 plus 1 is 2 plus 2. 2 times 2 is 4. 4 plus 1 is 5. So I'm looking and I'm saying, wait, negative 6 over 5, negative 12 over 30. Oh, wait a second, this is not reduced. Okay, so if I divide by 6 on the top and the bottom, if you take a look at what I get, okay, divide by 6 and I'd get a 2. Okay, and divide by 6, I would get a 5. So that means that I made a mistake over here. Let's find out what it is. Okay, I'm sorry, this is positive 2 minus 4. I plugged in a positive 2. Okay, so 2 minus 4 is negative 2. That's my mistake. Okay, so I apologize for my mistake. I plugged in a negative 2 in the numerator. I was supposed to plug in a positive 2, right? So I just did a little check for myself there. saw a mistake and I knew I had to go fix something. So 2 minus 4 is negative 2. I still get a 5 on the bottom. The reduced version of h of x over k of x comes out to also be negative 2/5. So we're good either way. I'm going to get the same result. Okay, you can plug into the original function or you can plug into the simplified version. All right, we have one more problem that we're going to do. Okay, in each of these problems, I'm giving you an h of x, or I'm giving you expressions. Okay, so I'm giving you just a bunch of functions down here, j, k, h, and f. So this first one I'm saying use k and j. All right, here we go. K and j is going to be k on top, negative 6x squared minus 2x, and j on the bottom will be negative 3x squared minus x. So I need to factor this expression. Right, so if I factor the numerator, it looks like they have just a GCF of negative 2. So let's remove that. Negative 2x, okay, and it looks like I'm left with 3x plus 1. Okay, my denominator, I'm going to look at this and say, okay, this has a negative x in common, so I'm going to remove that negative x. Okay, and that looks like it's also going to leave behind a 3x plus 1. Okay, so here's my cancel. Lots of things are going to cancel. 3x plus 1 and 3x plus 1. Okay, an x is going to cancel with an x. A negative sign is going to cancel out a negative sign. The only thing that's left here is 2. The entire expression just turns into a 2. Okay, let's do domain restrictions real quick. My original factored function had x. That cannot be equal to 0. Okay, and 3x plus 1 cannot be equal to 0 as well, which this one's going to give me x is equal to negative 1/3. So I'm going to say my final answer, all said and done, k of x over j of x is going to be 2, but x cannot be equal to 0 or negative 1/3. Okay, final answer. Okay, one more problem and then we are done. Same idea. Okay, I'm going to say in this case 2x squared minus 32 is going to factor twice. And again, I'll let you do the factoring. It factors into x plus 4x minus 4. Okay, and on the bottom, 8 minus 2x. Okay, it looks like it has a 2 in common, so this turns into 2 times 4 minus x. Okay, so let's do our canceling. I see a 2 and a 2. Okay, that cancels. I see an x minus 4 in the numerator and a 4 minus x in the denominator, and I'm looking at those and saying they kind of look close, but they're not exactly the same. Okay, they're off by exactly a negative sign. So if you take a look, this has got positive x, that's got negative x. This has negative 4, the bottom one has positive 4. So if I want to cancel them, I can, but I need to switch the signs on one of them. So in this case, I'm saying, well, I'd like this to really become negative x and positive 4. But by doing that, I need to pull away a negative 1 on the outside, right? Because negative 1 back into these would switch it back to the way I wanted. So now I can cancel this out and say negative x on top, positive 4 on the bottom. Same thing's happening here, but it's going to leave behind the negative that was throwing things off. So my final answer here is negative 1 times x plus 4. Right? Everything on the bottom canceled. And you could also write this if you want as negative x minus 4. Either way is fine. Okay. My domain restrictions, in this case, it looks like the only thing in the denominator was 4 minus x. So again, I'll come off to the side here. 4 minus x. When is that 0? Okay, again, I'll let you do the work. That's going to be 0 when x is equal to 4. So I'm going to say x is not allowed to be equal to 4 for my answer. So I'd say this right here is my entire answer. Okay. Negative x minus 4, but x is not allowed to be equal to 4. Okay, so again, you can see there's all these little subtleties. In this first one, I had a bunch of things canceling, right? The x is canceled, the negative sign's canceled, but I still had to worry about my domain. Okay, in this one, I actually had an issue where they were off by a sign, so I actually had to fix that as well. Okay, so lots of little different examples when we are dividing.